Hello everyone, welcome to this tutorial that is part of the course Clinical Research, Principles and Practice, and this bit is about prognosis and diagnosis. And to do a little bit of work on this, we're going to be using SPSS quite a lot. So before we get into the nitty-gritty of the multivariate modeling, we will first go in a little bit into the basics of SPSS. So here I've opened a data set, the renal failure data set. Here we have a list of variables with their according type, value labels if available, and variable labels. So we first want to look a little bit into this data set. And to do so, we can go into Analyze, Reports, do a quick descriptive, quick case summaries. So basically, we select a bunch of variables. You can hold down the Shift key and left click to select everything, and we'll just show the top 10 cases. I'm not going to do this for everything. I just want to make sure that there are some meaningful variables in there. So a gender, blood pressure, for instance. Let's do some proteinuria, urea, and creatinine. We paste this to the syntax window, which I have already opened. Here we have the syntax window. I'm just going to cut this and paste this up here. So here you see I've got a similar command already in place. So I'm just going to delete this and run this instead. So you select, click the green arrow to run it, and then we get the case summaries. So we see that there let me just check this and run it again. I noticed a little error in the output window, so I just want to check. Okay, here we go. This is correct. So basically, here I saw an error somewhere, and just to make sure that everything goes well, and rerun it. So we here have the description of the first 10 cases as we selected, and this is basically showing the same as you can see in a data frame, right? So this is basically the same summary as we see in the data view. Second, we want to do some calculations. For instance, in the data, in the variable view, we can see that we have the weight and the height, but we haven't calculated the BMI, for instance. We have the date of birth, and we have the first follow-up date, baseline date, but we haven't calculated age, for instance. And we want to calculate these because these may be important variables. So how do you do this? You can do this with a compute statement. First start with BMI. So to compute, you can either type this if you know the commands, or you go to transform, compute variable, and we can call our target variable BMI. You can use capitals. I prefer to use lowercase because this makes reading your code slightly easier. So we have the weight in kilograms, and the BMI is the weight in kilograms divided by a bit of lag, sorry. Divided by the height. But we know that, for instance, that height is in centimeters in this case. So we have, for the BMI, height should be in meters. So we divide by 100, and we square the height in centimeters, which is the double star in this case. This means to the power 2, and we do the paste again. Sorry, connection seems to be a little bit laggy, but it will work. So if we run this, the compute only, you'll see the line is executed, and if we go into the variable view, we see that actually the placeholder has been created for BMI, but if we double click this, we jump to the data window, and we see nothing has been created yet. That's correct. It's only going to create it after we run the execute. So now if we jump to the data window, we see that BMI is calculated. This can be used to make SPSS a little bit more efficient. So you can compute multiple variables, and only at the execute you have the computer run. And if you're doing multiple calculations, that's when you basically go get a coffee. So for age, it's slightly different. We're calculating with time variables, so we go again to the transform, but this time we run the date and time wizard. And here we have several options. We have some basic tutorials, but what we want to do is calculate with dates and times. And age is a duration, so we simply do that. So, let's go back. Wrong one. Create a no, this was the correct one. Sorry. Calculate the number of time units. That's the one we should have. Sorry. Okay, so date 2. If we right click the list, we can display variable names. This is also useful. I tend to work on the variable names a lot more. So we do date 1. This is the baseline date minus the date of birth to calculate the age. And as age is always rounded down, we say truncate to integer. Next, and then we still have to create the variable name, which we call age, with the label baseline age in years, and paste to the syntax window. I recommend you to always paste your work to the syntax window, because this is going to be basically your lab journal. This is a way to make sure that you keep track of what you're doing. So here we did the calculations, we see the code run, and if we go to the syntax window, we see that our age variable has been created. Now, okay. So we can do we can use the compute through transform compute. We can use the data time wizard. We can look at some other, and we can now also look at, for instance, some initial results. We do this. I do this here with the frequency statement, and this can be found under Analyze, Descriptive Statistics, and Frequencies. And I want to look at, for instance, blood pressure, also gender, proteinuria, creatinine, bicarbonate, calcium, phosphate, albumin, HB. Let's do some cholesterol as well. Total cholesterol, LDL cholesterol. This is a blood sugar parameter, BMI and age, the ones that we just calculated. So if we're going to do this, we're going to get very long frequency table, because each unique value, for instance, for serum albumin gets displayed in the frequency table. So we tick the box off, and now it's saying, well, you're not generating any output, and that's correct. Instead of the frequency tables, we want to do some statistics. So we select the mean, the standard deviation, and quartiles. Basically, this means the 25th, the 50th, which is the same as the median, and then the 75th percentile. Continue, and again, we do the paste. Before we do this, we also add histograms, and we can show the normal curve within the histogram. Click the paste, and we run this. It takes a little bit of time to process because we're generating lots of charts. So this is our first results, the tables. So we see we have 788 values for most variables, not for all variables. There are some missings. And we see, for instance, that the mean systolic blood pressure is 135 mils of mercury. And the median is 133, which is a sort of an indication that the systolic blood pressure is kind of normally distributed. For serum creatinine, the mean is 181, whereas the median is somewhat lower, indicating that this might be a little bit skewed. And if we look at the histograms, we see that this is more or less a normal curve. The same holds by systolic blood pressure. You don't really expect a 1-0 distribution to have a normal curve, basically. But for instance, proteinuria is clearly skewed with a right tail distribution, and the same holds for creatinine. And this is going to be important information for later on to select the analysis we want to use. Finally, we're going to do something a little bit more complex, and that's using a do-if statement. So we want to run an analysis at some point, and to do so we need to create an outcome variable. I've already created it here, but basically we have two dates, one signifying the date of the outcome. The outcome in this case is a doubling of serum creatinine, renal replacement therapy, meaning dialysis, or death, or the date of the last follow-up measurement. And people who do not have a outcome date, they do not have the outcome, and they need to be be coded as they need to have a follow-up time that ends at this date, and people who do have the outcome, they need a follow-up time that ends at this date. So we need to calculate a new variable using three variables basically, and that's what we can do with the do-if statement. So here we first use the date and time wizard to indicate that if we do not have a missing value for date outcome, we use the date outcome minus the baseline date, and if we do have a missing date outcome, remember then they do not have the outcome, then we use the final follow-up date, and we run this to create the time variable. This can also be done through the date and time wizard. So here we have our times, and as we are going to use a logistic regression model, we need to make sure that the follow-up time is the same for everyone. So we truncate the follow-up time at 5 years. And for this we do use a do-if statement, which basically means that for the people for whom this condition is true, then we say basically, so if your follow-up time is less than 5 years, then the current outcome value is correct, so outcome equals outcome. Otherwise, the outcome is going to be 0, because if you have an outcome value of 1, if you have the outcome after 5 years, then we want to replace it to we truncate your follow-up to 5 years, and at the time point 5 years, they did not have the event, and we reset the time to 5 years for those people as well. So, and here we do not create a new variable, but we've overwritten the outcome variable. So we have time. Right before this was 7, for instance, and now this is going to be 5, and this person does not have the outcome. Okay, so that's it for the data editing for now. If you have any questions, please post in the comments below. So thank you for your attention, and see you for the next video where we'll be covering some univariate statistics.